What is going on, everyone? Back at it with another video on what is it? Linear transformations, and we are doing another example. Hopefully, this one's like much more shorter. We're just gonna mainly focus on finding the image and pre-image of a or given a function. So we have four examples. I think that's what I put. But we are gonna get right to it. Well, actually, no. I'm gonna do a small little review on what an image and pre-image is. So before we get started, let's talk about what an image and pre-image is. So if we have a function t and two vectors, we know that the transformation of t of vector v is equal to w, and our w is our image while our v is our pre-image. And so to get the image, well, you just plug in v into the function, and then let the function do its thing, and it'll spit out our image. And to get our pre-image, given our image, we just kind of have to undo the function, pretty much work it backwards. So we're going to go ahead and do that with these examples, and we're going to start off with the first one. So the function given a vector v, we can get our image to be v1 plus v2, and then our other point would be v1 minus v2. Our image is literally going to be our v, which is going to plug in our v into this function. And so this would be 3 minus 4, and then 3 minus -4, which would be 3 minus 4 is -1, and then 3 plus 4 is 7. So that is our image. And then our pre-image, well, you just work it backwards. We know that this is our image, and so we know that 3 is equal to v1 plus v2, and we also know that 19 is equal to v1 minus v2. We can just do a little bit of what's that thing called, manipulation and then substitution to get that our v1 is equal to 19 plus v2. Plug it back in this first equation, so we'll have 19 plus 2v2, because we got this v1 plus this v1, and it's equal to 3. Subtract both sides by 3, and we have, crap, what's 19 minus 3? 16. Don't forget the negative, because it's 3 minus 19 is equal to 2v2, and then we get that our v2 is equal to -8. Plug it back into this equation, so v1 is equal to 19 minus 8, and that is 11. So our v is going to be, our v1 is the first one, order does matter, then our v2 would be -8. All right, cool, that was fun. So now let's up it up a bit, because this example was from R2 to R2, and we know that because we are given two numbers and we spat out two numbers. And so for our next example, we are given two numbers, inputting two numbers in a function, and we're spitting out three numbers. Whoa, we can do that? Yes, we can. Yeah. We can. So let's do the same thing. Image, just plug in our 0 and 6, and that is equal to 2 times 6 minus 0, then 0, 6. Oh, how lovely. What's 2 times 6? 12. 12, 0, 6. So that is our image. Our pre-image, well, this one's really easy, because in our function it tells us to spit out v1 and v2 by themselves. All I really had to do is just look at the last two, and that will be our image. So our image would literally be 1, 2. And you can check it yourself. So we can do a little quick check. So 2 times 4. 2 times 2 is 4, minus 1 is 3. So, yeah. That seems about right. Alright, so last two examples. Ooh, the last example, we're getting a little feisty. So, last two examples. We are given... Oh, okay, yeah. So this previous example was from R2 to R3. And now this one. This one is from R3 to 1, 2, 3, 1, 2, 3. R3. Alright. So let's get started with the image. So this is our V. So we're gonna plug in 2, 3, 0, and that is gonna be 3 minus 2, 2 plus 3, and then 2 times 2, and that would be 3 minus 2, 1, 5, 4. So that is our image. Our pre-image, well, literally, this is gonna be very interesting because we saw that our function only works with v1 and v2. So like v3 just kind of disappears, and we're gonna see what we can end up doing with that. So we can, yeah, break these numbers down. So we know that negative 11 is equal to v2 minus v1. Negative 1 is equal to v2 plus v1, and then 10 is equal to v1. We can start with the bottom, and v1 is equal to 5 because that was like the only variable. And then this one, do the top part, would be negative 6 is equal to v2, because you have v2 not minus, v2 plus 5 is equal to negative 1. So you subtract both sides by 5, and you have negative 5 minus 1 is equal to v2, which is negative 6. Then we can confirm on this one that v2 will be negative 6 minus 5, which is indeed negative 11. So our pre-image would be v1, 5, v2, negative 6, and v3. Well, see, that's the thing. We don't have a way to find v3, but we do know that when you take the pre-image, put it into the function, and it spits out our image, our v3 will be completely non-existent. So v3 can't just be a free variable. We're just going to call t. So that is our, this is supposed to be an equal sign. So so our v will be 5, negative 6t, where t is any real number. Because when you put it into the function, it's completely irrelevant in our w, or our image. So, last example. We are given a vector of R2, and it goes to 1, 2, vector of R3. Whoa. So, let's start with the image, since that's probably much easier. T1, 1 is equal to root 2 over 2 times 1 minus root 2 over 2 times 1. And then this would be 1 plus 1. This would be 2 times 1 minus 1. And so that will simply be, cool, they cancel out, 0. What's 1 plus 1? 2. What's 2 times 1? 2 plus 2 is 1. This is 1. Why did I say that? Okay, so this is our image, imagen. And now we have to work with our image to get a pre-image. Whoa. So right off the bat, we got a negative 5 root 2. Ew, who likes a root 2? Negative 2, negative 16. Again, we can break these up. We know that negative 5 root 2 is equal to root 2 over 2 v1 minus root 2 over 2 v2. And then we have negative 2 is equal to v1 plus v2. And then negative 16? Yeah, negative 16 is equal to 2v1 minus v2. Well, we can do the quick substitution here and get that v1 is equal to negative 2 minus v2. Plug it in here on the third equation, and so we get that negative 16 is equal to 2 times negative 2 minus v2 minus v2. So that would simply be negative 4 minus 3v2. And so that, again, that's equal to negative 16. So we have add both sides by 4. And so we have negative 12 is equal to negative 3v2. And then we get v2 is equal to 4. And so this, our v1, is equal to negative 2 minus 4, which is negative 6. Yeah, 6. And then we can double check with this one where, well, I mean, if we multiply both sides by root 2, we'll have negative 5 is equal to v1 over 2 minus v2 over 2. Plug in numbers, because we like numbers. What's our v1? Negative 6 over 2 minus 4 over 2. Negative 6 over 2 would be negative 3 minus 2, which is negative 5. This checks out. That means our v1 is equal to negative 6. Oh, that is so disgusting. That is so disgusting. Let me rewrite this. So our v, or preimage, is going to be negative 6 4 QED, and that is all that I have for the examples, I think. And wow, I feel like this became so much easier. I really hope that. So in short, all we had to do is to find the image and preimage. Well, to find the image, well, if given our preimage, you just plug in the preimage into the function and spits out the answer. If you want to find the preimage given the image, well, you just gotta undo the function, just work it backwards. 9 times out of 10, if not probably 10 times out of 10, it's just kind of working with the systems of equation. For the most part, well, in terms of here, you can easily do a quick substitution instead of doing those matrices that take a lot of work. But for the most part, you should do substitution and undo the thing. The only quote-unquote issue is make sure you know how to do your algebra, because I mean, errors can happen, and your arithmetic. A lot of people forget their basics, like me. Yeah, because when I did this, I think the last one I got negative 6, negative 4, and I forgot about the negative. Yeah. But yeah. So yeah, hopefully this video's helped, and then next one we will talk about what's the thing called? Linear transformations, showing that a transformation is linear transformation. So until next time, bye.